You've probably heard that HTTP 2 fixes head-of-line blocking, but it doesn't. Not completely. It pushes the problem one layer down to TCP, and that's why we now have HTTP 3. The original HTTP 1.1 gave us persistent connections and pipelining, but the big limitation was head-of-line blocking at the request level. Browsers worked around it by opening up to 6 parallel TCP connections to the same origin. That helped, but 6 connections is costly. Each connection has its own congestion window, its own handshake, its own memory overhead, and you still could get stuck. If one request on a connection was slow, the next one queued behind it had to wait. HTTP 2 introduced multiplexing. Now all requests and responses share one TCP connection. They're split into frames, and frames from many streams are interleaved. This solved the application layer head-of-line blocking. You could send the HTML, the CSS, and the JavaScript in parallel over one connection, and no single slow resource would block the others. This was a massive improvement. But here's the catch. HTTP 2 runs over TCP, and TCP guarantees in-order delivery. If a single packet is lost, TCP withholds all subsequent data until that lost packet is retransmitted and acknowledged. That means every multiplexed stream hits the same wall. This is TCP head-of-line blocking. A single lost packet can stall your entire page load. Even 1% packet loss over a Wi-Fi network can cause a visible delay. For a web page with dozens of resources, this is a real problem. Imagine a checkout page on an e-commerce site. It needs a small API call to validate the shopping cart and a large, non-critical product image. On HTTP 2, if a packet from the image stream is lost, TCP blocks delivery of the API response too. The Place Order button freezes, even though the actual vital data is ready on the server. That's the real-world pain of TCP head-of-line blocking. HTTP 3 fixes this by replacing TCP with QUIC, which runs over UDP. QUIC implements its own stream multiplexing right inside user space. Each stream is independent. A lost packet on one stream only blocks that stream. Other streams continue delivering data without interruption. In the checkout example, the API call stream is completely unaffected by a packet loss on the image stream. The critical cart validation arrives instantly. The user never feels the hiccup. QUIC also moves loss recovery to the application level. It can retransmit lost packets, not by sequence numbers that block everything, but by stream offsets. Only the gap in the affected stream needs to be filled. This is incredibly efficient. HTTP 3 has another trick, a zero round-trip time handshake for repeat connections. When you've previously connected to a server, QUIC can send application data immediately, alongside the initial cryptographic handshake. That shaves off a full round trip, tens of milliseconds on a busy network. Because QUIC runs over UDP, connections are identified by a connection ID, not by IP address and port. If you switch from Wi-Fi to mobile data, the connection just continues. No re-handshake, no new TCP three-way handshake. That's huge for mobile users. So, when does HTTP 3 really matter? It shines on lossy networks. Think mobile, public Wi-Fi, any environment where packet loss regularly hits 0.5% or more. It makes a measurable difference for sites with many small, interdependent resources, like modern web applications. Inside a data center, where packet loss is nearly zero and latencies are sub-millisecond, the overhead of QIC's user space processing can actually be slightly slower than TCP. If you're running a service mesh on a fast, stable network, HTTP 2 or even HTTP 1.1 with Keep Alive might still be the simpler, better choice. And IP3 is not a universal upgrade. Here's a rule of thumb. Use HTTP 3 when your traffic goes over the public internet and you care about the tail latency. If your internal services communicate exclusively inside a low-loss, low-latency cluster, the benefit is marginal and you might skip the complexity. To sum up, HTTP 1.1 suffered request-level head-of-line blocking, masked by parallel connections. HTTP 2 solved that with multiplexing, but inherited TCP head-of-line blocking, where a single lost packet stalls everything. HTTP 3 uses QUIC over UDP to give each stream independent loss recovery, plus 0 RTT and connection migration. Thanks for watching. I hope this one was useful. See you in the next video.